So session 2 is we will talk about the mean value theorem. In Chinese, we will say it's a 均值定理, 平均值, okay? 均值, okay? So before we just start to know what the mean value theorem is, we will focus on the Rawls theorem first. Rawls. So what is Rawls theorem? If y is equal to f of x is continuous at every point of a closed interval from A to B. Remember, including two endpoints is continuous, and also is differentiable at every point of from A to B is an open interval. So you will frequently see the situation for the later theorem. We will just focus on the function. It is a continuous function at every point of a closed interval from A to B, but differentiable at every point of the open interval from A to B. So not including the endpoint. We will not. We don't need to care about if the endpoint at the endpoint it is differentiable or not. We just focus on the interior. Okay. So based on this situation, if f of A is equal to f of B, then there is at least one number C in AB at which is the first derivative is 0. So maybe I can give you a picture or a figure to make you become more impressive. Okay, so the idea is just like this, that, okay, if there is a function s and y, this is a continuous function. So climbing up, then climbing down, or maybe possibly is climbing down and climbing up. Okay, so we just focus on this type. Then there is a here, and there is also a B here. The situation is these 2 points have the same function value. Okay? Okay, so if FA is equal to FB means they have the same function value. Then if F is continuous, okay, just like this is continuous and differentiable in between. So that means at each point we can calculate its derivative. It's differentiable. Okay? So if it just meets such kind of situation, there is at least one. So that means it is possibly, we can have 1, 2, 3, or even more. Okay, in this case, like C will be here. There is a C here. Its first derivative is 0. So did you remember the derivative means the slope? Did you remember slope? So there is a point in between A and B, and then its slope is 0. So I can find at least 1, right? But if in another case, then maybe it will be just like this one. From A and climb down and climb up. So, okay, we also can find there are 2 points, A here, B here. In this case, they also have the same value here. F of A is equal to F of B, right? So in this case, we can find how many points? Which first array is 0? 2, right? 1 is here. And the other one is here, right? So in this case, we have 2 points at which F prime C is 0, right? So we can find this point and also this point. So A is here, B is here, so maybe it's possibly climb up, then down, then up and down several times. If so, you can find more than 2. Climb up, then down, or up and down, then finally end at this point, and F of A is equal to F of B, then we can find several points at which F prime C is 0. So the only condition you need to make sure is F of A must be F of A must be F of B. Then you can find at least 1 point at which F prime of C is 0. Okay, so it's not that hard to imagine that every point, if it's continuous, it's a continuous function climbing up, then must climbing down, so that you can reach the point with the same value as A, right? So maybe it's also possibly like this case. Maybe in the beginning it's a climb down, but since F of A is equal to F of B, so you must climb up, then reach the another point, so the F of A is equal to F of B. So in this case, you can find another point, C here, F prime C is 0, right? So if the start point and end point have the same value, function value, then it must pass in a procedure climbing up, then climbing down, or climbing down, or climbing up. 你会碰到一个你只要有起点跟终点会相等，而且中间经过是一个连续函数的话呢，可微分，你势必会有一个上来再下去的动作，不然你不会碰到相同函数值的，对不对？所以同样的，它有可能是往下跑，然后再往上跑，相同函数的点，那中间一定要经过有一个点叫什么？它的一次微分为0，它的斜率为0，它是水平的，对不对？然后它才会下来嘛，对不对？就像你爬山上去，对不对？爬山上去总下山嘛，对不对？但是这爬山上去、爬山下来，会不会只有一个峰或一个谷呢？不一定，因为它有可能上去又下来，中间来回好几趟。那这时候我们就会说，它会有 more than 一个点是一次微分为0。Okay. Okay, so if you already have the idea, we can just revisit another question just like this. Show that s cubed plus 3x plus 1 is 0, has exactly 1 root of real number. So we can use Rolle's theory to prove it. So okay, so let's just try to prove it. The first thing is that f of x is equal to s cubed plus 3x plus 1. So it's a continuous function, right? It's a polynomial function. It's a continuous function. So it just meets the requirement that continuous and also differentiable. Because it's a polynomial function, it's also differentiable. Then we can see when we use f of 0, then we can get the function value is 0 plus 0 plus 1, so the answer is 1. Then we can also find f of minus 1. Then we can get minus 1 plus minus 1 cubed plus 3 times minus 1 plus 1. So the answer is minus 3. Negative 3. Then it's negative. So you can see here is positive. Here is negative. So we can find a root between 0 and minus 1, right? By using what kind of theorem? What kind of theorem? We just can prove it. Intermediate theorem, right? Do you remember intermediate theorem? If one is continuous, if you have points, its function value is positive, then you can measure another point is negative. Then you can be sure that there is a point, its function value is 0. Did you remember? So by using the intermediate, if you forget, you need to go back to check it out. In the theorem, then we can say I can find a C in minus 1 and 0. Minus 1 and 0, so that f of C must be 0. So at that time, we just proved that there is a root, at least one root between minus 1 and 0, right? But this time, the problem just asks us to prove that there is just exactly one. Exactly one. But so far, we just show that there are roots, but I'm not sure how many roots between minus 1 and 0, negative 1 and 0. I'm not sure. Because maybe possibly there are like minus 0.5 is positive, then minus 0.3 is negative, then we can have another root there, right? But right now, I just, through this procedure, the step 1, I just know there is a root, at least one root. But the problem just asks us to prove that exactly one. So that means there are no more than 2. Only one. So if you just stop here, you cannot say, in this case, there is just exactly one root. You can just conclude that there are roots between minus 1 and 0. Okay? So you need to prove it furthermore that, okay, we just assume there are two more roots of real number. So if we have 2 more, that means for example, if 2 more, maybe S1 and S2. Okay, so that means if they are S1 and S2 are roots. We must have f of x1 is 0 and f of x2 is also 0, right? If we assume, if our assumption is correct, f of x1 and f of x2 must be 0 at the same time, right? So you can see in this case, f of x1 is equal to f of x2 because both of them are 0. So f of x1 and f of x2, both of them are 0 by since. So we can find a c in S1 and S2 such that f of c is f prime c is equal to 0. This is by the Rolle's theorem, right? So we can find f prime c is between x1 and x2, then its function, its derivative is 0, right? Rolle's just tell us that if we can find 2 points, these 2 points are different, but they have the same function value. Oh yeah, right? So we can find c between x1 and x2, then its derivative should be 0, right? However, we can find the step 3 that, however, when we just differentiate f of x, then we can get 3s squared plus 3, always positive. So that means no any value, no any point can make the derivative value is 0 because all of them should be positive. So there is a conflict, right? So hence, we only have one root for f of x is equal to 0, right? So based on Rolle's theory, we can have 1 point is first derivative is 0. However, through the procedure 3, if you just differentiate the function, then you can get the derivative function is 3 times x squared plus 3. So it is always positive. It cannot be 0, right? So there is a conflict between step 2 and step 3. So that means our assumption is not correct. Our assumption is there are more than 2 roots for this case, but it's wrong. But for the procedure 1, we prove that we have roots. But we cannot, through procedure 1, we cannot measure how many roots there. So that means there is maybe 1 or 2 or 3 or even more. But through some assumption in step 2, we assume we have more than 2. However, through procedure 3, we just prove it's impossible. So finally, we can conclude there is only 1. So we can just conclude we just have only 1 root for this case. Okay? Okay, which one? Because we just see, we assume there are 2 roots. What is root? If E is a root, when we use the number as the input for the function, then we can get a 0. 如果它是个根，代线函数 f of x 应该会得到0，对不对？根 了解吗？根就是它的函数只是零，所以我们假设有两个的话，那这两个是都没有要零，对，两个都要零。那两个都要零的情况之下，那就符合 Ross 的定理，对不对？两个端点啊 ，S1 是一个左端点 ，S2 是一个端点，这两个之间应该还会有一个点，让它一次为1为0。OK， 但是步骤3就证明这件事不行，因为它的微分用是正，怎么可能会有对？这个假设就是有问题。这假设有问题呢，我们第一段就说它一定有根，那代表什么？一定有根，扣掉你不能有两个以上的根，那就只剩下一个根，这样了解吗？哦 ，OK。So then we will go into Theorem 4, the mean value theorem. What is mean value theorem? Actually, it's quite similar to Roll's theorem, but there is something different. As Roll's theorem, we need to have the condition of f of a is equal to f of b. But for the mean value theorem, it's more general. So let's just see how the statement is. Let's suppose y is equal to f of x is continuous. Also on AB, cross interval, and differentiable on the open interval AB. So you can always see the precondition. Okay, so then there is again at least one point C between A and B, at which f of b minus f of a over b minus a is equal to f prime of c. Maybe it looks more complicated than the Roll's one, but later on I will show you. It's quite easy to imagine it. So, okay, I also draw a figure to impress you. S and y, if I give you y is equal to f of s, then the f of s is just like this, right? So if a is here and b is here, so this time f of a could be not equal to f of b, right? Because f of a is here, f of b is here. But for rows, these 2 points should have the same point value. But for the general one, I mean the mean value theorem, these 2 points don't need to have the same function value. So you can see f of a is here, but f of b is here, right? So very similar statement is here, that we can find a c. We can find c between a and b. So that means I can find a c somewhere between a and b, at which f of b minus f of a over b minus a, what is this? You can just regard this as just link these 2 points together, right? And then this part will be its slope, right? So f of b minus f of a, f of b minus f of a over b minus a is its slope, right? Then I can find at least one point C between A and B. Its first derivative will be the same as the slope. So how can we treat this? So that means FC is here. Its slope, its first derivative is here. So the first derivative for f of for C is this one, right? And if you just link these 2 points together, then we just try to calculate this value. It will be the slope for this line, linking these 2 points together. So you can see if these two ones, based on this idea, that actually we can say its derivative is same as the slope for this one. So maybe if you cannot discard the image, then you can just change your viewpoint. You can slightly, for example, you can slightly rotate this figure, or rotate yourself from this angle, You can see, if you just see this curve from this angle, from this viewpoint, you can see these 2 points at the same height, right? And this will become a horizontal line. No, this way, not this way. Okay? You can just assume your eyes is here. Your eye, how can I draw eye here and see from this view, right? And you can suddenly find it's almost same as this one, right? 很不好看吗？我画的太丑了。你假设你看看你的眼镜，如果在这里朝向这边去看这个曲线的话，它的效果是不是跟这个是一样的？同高，对不对？所以你从这边角度去看，哎，同高，所以这两个连起来，中间的这个一定有找到一点 C 呢，它的这个刚好是水平线，它的切线刚好是水平线，所以这个 ρ 它等于把 ρ 的定理呢，在扩增到一般性的时候呢，它就不要求 FA 跟 FB 一样相等，但是它们两个之间的连线斜率刚好会恰巧等于 C 介于 AB 之间，它的一次微分为跟它的斜率是一样的。So yeah, so again, maybe there are many points. You know, so for example, I can draw a small one for you. That if the curve maybe it's possibly like this way, right? So if A is here, B is here, so you just link them together. There are 3C here, here, and also here. These 3 points, for example, if this is C1, this is C2, this is C3, all of them have the same slope as the one linking these 2 endpoints together, right? 这三个点跟这两个点连起来的斜率啊，这三个点的一次微分的值高跟这两个点连线是不一样的。所以以这个例子来讲，我只找到一个。以这个例子我可以有3个，这跟 ROS 是很像。唯一 ROS 跟 mean value theorem 不一样的地方是 ROS 它是水平的。那我们把它稍微拉斜一点点之后，你会发现这样还是0。这不是0啊，只是斜率相同。这两个因素斜率相同，代表这两个表现平行，对不对？这个切线跟这个连线，那这个是两点连线的斜率，那这个是它的切线斜率。那这3个点呢，它们的斜率刚好都跟这个绿色的线是一样的倾斜程度。Okay, so actually the mean theory mean value theory is very important because we can just extend the idea to some corollary. Then that also will be linked together with our indefinite integral. So it will be related to integral. 这个跟积分会有关系哈，不定积分会有关系。Okay, so let me just show you the first corollary. What is corollary? Corollary means we just have a main theory here. We have a main theory here, and then we can just extend the idea to get more results. We can regard it as a small theorem, but actually the idea is totally coming from the main theorem. Okay, so for the corollary one, if f prime x is 0 at each point x in AB, then f of x will be a constant function for all x belongs to AB. So let me repeat the idea again for you, that you just focus on here. If f prime x is 0 at each point, remember at each point, so all points between A and B, its first derivative value is 0. So you can just imagine that if it's a continuous function, at each point, its slope is its first derivative is always 0, so that the tangent, the slope for the tangent line is always 0. So only one situation can have such kind of result, that only f of x is a constant function. This is a constant function. Have the result, can follow a result. Yes, because you can see at each point its first derivative is 0. So that means at each point its tangent line is horizontal line. So you know what I mean? Only this situation. At this point is derivative 0. This point is 0, and z, f of z is 0, right? So at each point, you always have a horizontal tangent line. So only constant function have meet the case, right? And then we also can have a quick proof for that by the mean value theorem. For any x1 and x2 belongs to AB. So I just randomly pick up 2 points from AB, right? AB is open interval. Then I just randomly pick up x1 and x2 from the open interval. Then we can see, we can find an x between S1 and S2 such that f prime x is equal to f of x2 minus f of s1 over x2 minus s1, right? This is based on this theorem, right? So when I randomly pick up s1 and s2, I can always find an x between s1 and s2. Then its first derivative is equal to the slope linking these 2 points together, right? Yeah. Linking these 2 points together, and then we can find a c in between, and its slope is same as the slope. Its first derivative is same as the slope. Okay, so and based on this statement, f prime x is always 0. F prime x is always 0, right? F prime x is always 0. So this equation will also is equal to 0 because of the statement. So that we can get f of x2 minus f of x1 is 0. So that f of x2 is f of x1. So you just randomly pick up 2 points, and these points are different, but finally its function value, these two function values are the same. So only one situation can meet this result. That means f of x must be a constant. Otherwise, you cannot have such kind of result. Understand that? 好，我们快讲一下。好，这函数如果说这个引理是一次微分为0，在所有的点在某个区间来说呢，那么我们可以推论它一定会是在这个区间里面是一个常数函数。好，先把这 statement 搞清楚，它在讲什么。我再讲一次哈。如果我在某个区间所有的点它的一次微分为0，那么这个函数在这个区间一定是一个常数函数。为什么呢？我们根据这个君子定理告诉我们说，我随便在 AB 里面随便找2个点 S1、S2， 随便找哦，但这2个点要不一样一样就没有意思了，对不对？我随便找2个点，那根据定理4告诉我们说，我一定可以找到一个 S 介于 S1 跟 S2 之间，它的一次微分跟我连线的斜率是一样的，懂吗？好。所以我的斜率是这样子，我的这个 S 的一次微分是这个样子，它们两个一定要相等。那同时呢，这个题目告诉我们说，它在这个里面的任何一个点，它的一次导数都是0，代表什么？这个通通是0。那所以在这种情况之下呢 ，S2 跟 S1 不相等的情况之下 ，f of S2 减掉 f of S1 一定要等于0，它一定等于0，这个2个点一定要等值，所以我任意取2个点，它们2个永远等值，代表什么？这个一定是一个常数函数才有办法做到这样子，对不对？不然你怎么有办法保证任何2个点带进去的函数值都是一样多呢？了解吗？ Okay, this is the first corollary. And for the second corollary, 2 is if f prime x is equal to g prime x at each point S in AB. Again, at each point S in AB, then its original function f of x and g of x, the only difference is the constant. So let me just state the statement for you again, that if there are 2 functions, f of x and g of x, I just know its first derivative is same as its first derivative. That means f prime x is equal to g prime x. Okay? And we also know that at each point, this equation just holds. Then we can know its original function. You can see this is f prime x, this is g prime x. So its original f of x and its original g of x, the only difference is one constant. Okay, so then I will show you how to prove it. When I show you how to prove it, I just threw the proof to remind you the concept about the mean value theorem. So when I want to prove it, please just take h of x is equal to f of x minus g of x. So that I just differentiate this at the both sides. I can get this one, right? I can get this one, right? I just differentiate them at both sides, then I can get this one. Of course, I assume f of x and g of x are differentiable, so I can do this at both sides. Since you just told me that f prime s is equal to g prime s, so if f prime s is equal to g prime s, so what's the result? What's the result? What's the result? It should be 0 because they are the same, right? They are the same. So when we just subtract f prime s subtract g prime s, it should be 0. So if it is 0, so you can see f prime x is 0, right? So based on corollary 1, just this one. If it's a constant, if its first derivative is 0, we can say f of x should be a constant, right? Based on this, if its first derivative is 0, then we will say it's a constant function. So based on this, h of x should be constant. So then let's just roll it back to the original one. F of x minus g of x should be c, so that we can get f of x is equal to g of x plus c. Okay, so we just prove it. Okay, so let's just stop here for a while and then come back in 10 minutes. Okay. Okay, so I just want to give you an example to show you how to apply these corollaries. So this example is just like this. Please just find the function f of x whose derivative is sine x. Okay, so that means I didn't know what f of x is, but I know its derivative, right? I don't know what f of x truly is, but I just know its derivative is sine x. Okay, so this is the first statement. Then, and whose graph? So that means its curve just passes through some certain point, 0 and 2. So please just tell me what this function is. So that I understand the statement of the question, right? I just want to ask you to give me the f of x, but I just show you some clue that its derivative is sine x, and it also passes 0 and 2. So what is this? So based on the condition, the problem just gives us that since f prime x is sine x, right? This is the problem statement just gives us. Yeah. Then we also know, this is very important, we also know 1g of x, it is minus cosine x. Why we just choose minus cosine x? Because g prime x is also sine x. So right now, if I choose g of x is minus cosine x, then I can make sure g prime x has the same derivative of f of x, right? So based on this, therefore f of x must be minus cosine x plus c based on corollary 2. Because corollary 2 just tells us that if these two functions, f of x and g of x, is respective derivative f prime x and g prime x are the same, then we can conclude that f of x, the difference between f of x and g of x is a constant c. So based on this, even though I don't know what f of x is, but we know its first derivative is sine x. Based on this, I try to design another function g of x. If g of x is equal to minus cosine x, then g prime x is sine x, so that they can have the same derivative. These two ones have the same derivative, right? So we can conclude this one. Then they also show since f of x passes 0, 2, so that means when I put 0 as an input, then I can get 2, right? So if I put 0, that means minus cosine 0 plus c. So minus cosine 0, this is minus 1 plus c, so that c is equal to 3. Right? If f of x passes 0 and 2, that means when I use 0 as an input for this function, then I can get a function very speed. Right? So 0, then I can get minus cosine 0 plus c. So minus cosine 0 means minus 1. So that's why c is 2. So with c is equal to 3, then I just go back to this equation that I can get. So finally I can get f of s is equal to minus cosine s plus 3. So this is the final answer. Okay? So this is section 4, the section 2. Section 2. Then is it okay? So for section 2, we just focus on Rolle's theorem and also the mean value theorem. Especially mean value theorem is very, very important. And in the later chapter, we will also mention this part, and then especially in the integral. So later on, we still will face this theorem. But so far, these two corollaries also are very important. Okay, so let's just go to section 3, then monotonic functions, and the first derivative test. So what is a monotonic function? So we need to define increasing and decreasing function. Actually, these two functions, supposedly you are quite familiar with that, but we just have a formal definition for this. Therefore, that f of x be a function defined on an interval I. Big I means the interval, okay? And x1, x2 are 2 points in I. So that means I give you an interval I, and then I randomly pick up 2 points from this interval, S1 and S2. So if I randomly pick, and the first statement, if f of x1 less than f of x2, whenever s1 is less than s2. So you can see that the more x, the more function value, right? The more function, the more the input, the more the function value. So in this case, we will say f of x is increasing in I. So remember, in I is not its domain. Its domain may have several subintervals, you know. So I just focus on some interval I, not the whole domain. Okay, I can divide its domain into several pieces. Yeah. And this piece we can regard it as I. So later I will show you some example, then you know what I mean. Okay. Similarly, if we want to define decreasing, that will be if f of s 1 larger than f of s2, whenever s1 is less than s2. So you can see the more the input x, the less the function value, right? S2 越大，你的函数值越小。这是 S2 越大，函数值越大，所以一个是递增，一个是递减。但记得它只是在这个区间而已哦，不是整个 domain 哦。Okay, so we will call this is a decreasing function in I. So we will say if a function that is increasing or decreasing on the interval I, we will call its monotonic on I. Monotonic in Chinese is mean 单调，单调的哦 ，monotonic 只有一种样态啊，单调的意思是这样，就只有一种样态的概念啊。Okay, so I will show you the corollary 3. So the corollary 3 just extended by the mean value theorem. So that's why we call it corollary 3. So we already know corollary 1, corollary 2, then right now we just focus on corollary 3. This is the first derivative test for monotonic function. So suppose that f of s is continuous on AB and also differentiable. So we already see this precondition for 3 times at least, right? On the open interval AB, right? The precondition is just like this. Then if f prime x is positive also at each point. Remember, at each point, S belongs to A open interval AB. Then f of S is increasing on AB. So remember, you can see at each point, f from x is always positive. That means you can see it's increased. At that moment, it's increased. At each point, always increase. So we can just intuitively conclude that f of x is increasing on AB, right? So similarly, if f prime x is negative at each point, then f of x is decreasing on AB. Let me just emphasize that again. Only for this interval. Only for this interval. Yeah. Different interval, the function may have different behavior. 不同的区间，它可能不同的行为样态。哦，所以我要强调，你如果是在这个区间里面的每一个点都是正的微分值，你只有在这个区间是递正的，其他的要个别再讨论。好，看懂吗？不是全部的哦。好，对 ，OK， 一段一段，一段区间，一段区间的。So it's also easy to prove it. Again, why I just prove it? Because I just want to remind you the concept about the mean value theorem. Okay, so let S1 and S2 be any 2 points in AB. We can assume S1 is less than S2, right? We assume, because we can do that, because if I pick up S1 and S2, if S1 is different from S2, we can assign S1 is the small one and S2 is the larger one. Okay, so we assume S1 is less than S2. So by the mean value theorem, see, we just use the mean theory again. We can find a C in S1 and S2 such that upon C is equal to f of x2 minus f of s1 over s2 minus s1. So right now we already know it's always positive, right? Yeah. So it will be part larger than 0, right? And especially this part, because we say s2 is larger than s1, so this part is also positive, right? So finally, we can conclude f of x2 minus f of s1 should be positive, right? If it's positive, then we can get f of x2 larger than f of s1. So please notice here. If s2 is larger than s1, we can have f of s2 larger than f of s1. It is increasing, right? The more the input, the more the function value, right? Oh. So we can, from here to here, then we can call it increasing. So we can say it's increasing. So similarly, for this case, This is for this case. Similarly, for this case, we still follow that blah 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 blah, right? So, okay, maybe this is 1, this is 2, this is 1, this is 2. So again, we also can follow the statement blah 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 with S1 minus S is less than S2. Okay, and also by the mean value theorem, we always can find a C in S1 and S2 such that F plus C is also f of S2 minus f of S1 over S2 minus S1. Okay, but here f prime s is always less than 0. So that means here is less than 0. Yeah. Right? And we also assume S2 is larger than S1. So this part should be positive. So we can conclude this part will be less than 0. Less than 0. So that we can get f of S2 is less than f of S1. So we can say it's a decreasing. Right? So I just quickly prove it for you, but if you cannot memorize it, at least you need to memorize this. If in some certain interval, if all point is first derivative is always positive, we will say in this interval the function is increasing. If less than 0, the function is decreasing. Okay? So I will give you an example to impress you this idea. For example, f of s is equal to s cubed minus 12x minus 5. This is the original function, right? But you can see this is the first derivative test. So that means we need to calculate its first derivative, right? So if I calculate its first derivative, we can get 3s cubed squared minus 12, right? So we just defactorize it. Factorize it. 3 times s minus 2, s plus 2. It's not that hard. You can do it by yourself, right? Okay. Then, can you tell me which point is the critical point? Critical point. What is critical point? What is critical point? Its first derivative should be 0, or its first derivative should be undefined, right? So in this case, only x is equal to 2, or x is equal to negative 2, right? So based on this, the critical points will be s equal to minus negative 2 or s is equal to 2. So that we can just have draw the x-axis. If this is x is equal to negative 2, this is x is equal to 2. So in this interval, we just split it into 3 intervals. One is from negative infinity to minus 2, and minus 2 to 2, then 2 to positive infinity, right? Yeah. So from this part, for this subinterval, f prime x is positive or negative. From this part, positive, because when s is less than negative 2, this part negative, this part also negative. Negative times negative is become positive. right? For this part, in between, right? So this part, it will be negative. This is positive. So finally, this is negative. Finally, for this positive, positive times together, positive, right? So based on this corollary, we know if f prime s in for each point in this subinterval, f of s is increasing. So here we know it is increasing. This is decreasing. Then this is increasing. Right? So when s belongs to negative infinity to negative 2, it will increasing, right? Yeah. But after we cross over, just go across to at s is equal to negative 2, it will become decreasing when s belongs to negative 2 to positive 2, right? Then after we walk across 2, then the function will go up again. So s, when s belongs to positive 2 to positive infinity. So you can see there is a behavior going up and going down. So we can find there is a maximum value here. Yeah. Here, going down and going up, you can find there is local minimum. Yeah. Right? So here we can find a local maximum. Here is the local minimum. So it's the first. So how is that? Should I answer the phone? Okay, forget it. Okay, so later I will show you a theorem that if there is a behavior that going up and going down, you can have a maximum value. Yeah. Going down and going up, you can have a minimum value. So I will give you this, that we can have the first derivative test for the local extrema. What is that? This is very important. I already show you the example that suppose that C is a critical point, right? So just like here, I show you there are two critical points. So C is a critical point. So C is either this one or this one, right? So if C is a critical point of a continuous function, f of x, and that another suppose is f of x is differentiable at every point in some interval containing C, containing this C, except possibly as C itself. See, we just see this statement again. Why? Why did he just say differentiable at every point in some interval containing C? That means all points is differentiable. And then see. However, it said possibly at C itself. Because did you remember there are two types of critical point. One critical point is zero or undefined. If undefined, of course I cannot say it's differentiable. 记不记得我们当初讲 critical point 有两种要看，一种是为零，一种不可微分，都是属于 critical point。所以他在描述的时候，你会发现他这描述的时候也写得很清楚。他说，你在 fs 要在某个区间里面都要可以微分哦。对，这个区间里面都要可以微分。这个区间是什么？包含了 C 的这个区间。对。但是呢，可微分里面可以不包含 C 这一点。为什么 critical point 有可能它是导数是正无穷大负穷大，所以它就加注了这一句话叫 except possibly at C 以下，很重要哦。包含 C， 但 C 这点可以微分，也可以不可微分。哦 Okay, so this is a precondition. Then when we moving across C from left to right, one, if f prime s changes sign from negative to positive at C, then f of x has a local minimum at C. So the second thing is, if f prime x changes signs, but from positive to negative at C, then we will say f of x has a local maximum at also C. But if f prime x does not change sign, then we will say no local extrema at C. So it's quite intuitive, right? If f prime x changes sign means from positive or negative to negative, or negative to positive, two possibilities. So if change from negative, original negative means going down, decreasing. Then after C, going up because it becomes positive, right? Just like this. Negative. Here is negative, right? The sign of f prime x is negative. Then after this point, the sign of f prime x become positive. So from negative to positive, from going down to going up, we must find a minimum value here. Yes. Because s is equal to 2 is a critical point. Right? So similarly, you can also find this fact that it just changes sign here. This is sign of f prime x is positive. From positive to negative, crossing this critical point, negative 2, then we can see when x is equal to negative 2, we can have a maximum value here. So it's very intuitive, right? Oh, we almost run out of time. So I just give you the question list. And next time, if we still have time, I will show you another example. Otherwise, I believe it's very easy for you to understand the concept. Okay. So in this section, we just try to know by using the first derivative to test the function's behavior. Maybe if its derivative is positive, it will going down, it's increasing. If negative, it will decreasing, it's going down. Then through going down, going up to going down, we can have a maximum value. Through going up, down to going up, we can have another minimum value. Okay, but if we didn't change the sign, for example, maybe positive to positive, then nothing will happen. Okay, let's just call it a day. So remember, we just slightly reschedule the class time on Wednesday. Okay.